In this video, we're going to talk about the components of a linear program. I'm going to talk about it a little bit in the context of the LEGO workshop, but the next video will be talking specifically about how to map these four components to represent the LEGO workshop example. And so when we are trying to formulate a mathematical model, we're taking a written description and wanting to represent it mathematically. And so here are the four components that we have of a linear program. So first component you can think is our what. It's what our decision maker is trying to actually implement. So maybe you're a consultant and they've come to you and they want to solve a particular problem, and they are going to implement it. So it's a solution that they are looking for. This is our unknown. So we haven't been given any data about this particular component, and we represent this as decision variables. Our second component is our why. One second. That's better. So our why. So what makes one solution better than another solution? So you can think of this as our motivation or a goal that we're trying to achieve. And so this is what we represent in a component called the objective function. Third, there's often limitations on the decisions that we can implement. So it's not always that we can make millions of dollars or millions of a particular product because we have limited resources or limited demand or other things that are constraining what we can possibly do. So our third component here is our limits or restrictions. So like I said, you might have limited resources, you might have limited demand, and the action that you're trying to limit is represented as a constraint or a set of constraints. So we'll get to this, but the actual value of our demand is not our limit or restriction. It could be that we cannot produce more than what we demand, or we must produce at least as much as what they demand. That type of action is imposed in this limit and restriction. So constraints should be limiting some type of action corresponding to these decision variables. The fourth component is often tricky that people forget, but it's the data that we have associated with our problem. And so often when you have this model, you pull in data and you solve it. You determine what our solution should be. You determine how much your objective function value is going to be, but then you would often maybe solve for a different set of data for that same model and come up with a different solution. But your model doesn't fundamentally change. So if we think about LEGO Workshop, our model doesn't fundamentally change if he makes $3 per tee or $4 per tee. Our solution will change, but our model doesn't. In that case, it's the data that is changing. So you can think these are the values that we're giving. It could be money. It could be our amount of resources. It could be instructions. On how to make a tea or cake. We'll also get to this. I'm going to put it here and not really explain too much, but this is a set. And I'll explain this more, but think that you have groups or sets of different items. And this is what we call parameters. And let me make that look better. And sets. So just reviewing, we have 4 main components of a linear program. We have our what. It's something you read the description, you can't determine what it is, but it's what you're trying to solve for. We have our why, so what makes one solution better than another. Your limits or restrictions, so you're probably given some type of data on these, and it's limiting the decision that you can make. So I can only produce a certain amount of this, or I must produce a certain amount of this, or I can only use a certain amount of this resource. Then our 4th component is the data component, and so these are actual values. So when you look through your description, you're looking for values or something that is describing that something that you're known. It could be, we refer to this Excel sheet to know the distance between this location and this location, or we have forecasts on how much it's going to cost. Those types of things would be associated with the data that we have. And so that concludes this video about the components of a linear program.